This is a lesson on how to solve non-triangular systems of equations that have three systems, three equations, and three variables. Now, we already know that systems like this are triangular and that they are easily solved by back substituting. But what do we do if we have a non-triangular system with three equations and three variables? We're going to use elimination to create a triangular system. Now let's see how this works. It would be good if you wrote down all of these examples. No need to copy down the row labels and the column labels, but do write down the system of equations. We will begin by eliminating the variable in row 2, column 1. We do that first. Next, we're going to eliminate the variable in row 3, column 1. That will leave us with a 2 by 2 system, a 2-variable, 2-equation system in rows 2 and 3, which we know how to solve. So let's look at this in detail. Using that same system of equations, I want to eliminate the variable in row 2, column 1. It's an x. So I will multiply row 1 by -1. Now, why -1? Because I need to create a zero pair. I need to cancel out that x in row 2. So I need a -x to do that. So I'm going to multiply every term in row 1 by -1, and this is what I end up with. Then I'm going to take my new equation and add it to row 2. When I do that, I cancel out the x's in that position, and I end up with -3y plus 2z is equal to 1. Now, it's very important at this point that you rewrite your system with your new row 2. Okay, here's our system with our new row 2. I need to eliminate next the variable in the position of row 3, column 1. It's a 2x. So, since I need to get rid of a 2x, I need a -2x. I will multiply row 1 by -2 all the way across, and I'm going to get my new equation. I'm going to take that equation and add it to row 3. That will cancel out the 2x in row 3, column 1, and I end up with -y minus 3z is equal to -18. Again, it's very important for you to be able to keep track of your work that you rewrite your system at this point. Now I've got my new row 2, my new row 3, and you notice that in row 2 and 3, I have a 2 by 2 system. That is, I have two equations with two variables, and I know how to solve that. If I want to, let's say, solve for z, then I will multiply row 3 by -3 to create my equation that gives me a zero pair. And then I'm going to add row 2 with my new equation, and that gives me 11z is equal to 55. And folks, now it's really easy. I just divide both sides by 11 to solve for z. And I find out that z is 5. At this point, rewrite your equation again with your new row 3. I am sure you have noticed that now we have a triangular system. That's easy to solve. I know the value of z. It's 5. And so I can plug z into the second equation and solve for y. And I do that here, and I find out that y is 3. Now that I know both y and z, I can plug them both into my first equation and solve for x. And it turns out that x is equal to 1. Here is how we write that solution. We write it as an ordered triple. It looks like this, in parentheses, 1, 3, 5. And that this means that when x, y, and z have these values, all three of these equations are true. Let's look at one more example. Now I want to get rid of the 2x that's in the position of row 2, column 1. So I'm going to multiply row 1 by -2 to create my zero pair. Here is the equation I get. -2x minus 2y minus 10z is equal to -50. I am going to add that equation to row 2. And when I do, I get rid of that 2x. It cancels out with the -2x. And I end up with 2y minus 13z is equal to -86. At this point, we're going to rewrite our system with our new row 2. Next, I want to get rid of that 3x that's in the position of row 3, column 1. So by now, you probably have guessed that I'm going to multiply row 1 by -3. So I get a -3x. And I'm going to take that modified equation and add it to row 3. When I do, I eliminate 3x, that 3x in that position, and I end up with -5y minus 14z is equal to -64. And again, I'm going to rewrite my system with my new row 3. We are almost done with this one. By now, you have noticed that we have in row 2 and 3 a 2 by 2 system. I'm going to solve that with elimination as well. But you notice that neither one of these coefficients is 1. So I have a little bit more work to do to deal with a system like this. I'm going to multiply row 2 by 5. And I get this, 10y minus 65z is equal to -430. And then I'm going to multiply row 3 by 2. This creates a zero pair of 10y and -10y. So that when I add my two modified equations together, I get 10y and -10y, which is my zero pair. I also get -93z is equal to -558. When I divide both sides by -93, I end up with z is equal to 6. And so here we are. I have a triangular matrix, a triangular system. Now that I know that z is 6, I can use that in the second equation to solve for y. And when I do all of that math, I get y is equal to -4. Now that I know what y and z are, I can plug them into the first equation and solve for x. That means that when x is equal to -1, y is equal to -4, and z is equal to 6, all three equations are simultaneously true. Now, I hope that you paused and took plenty of notes and paid attention to all of the solving I was doing. If you have any questions at all, make a list of those in your notes and come to class prepared to ask your questions. I'll see you online in class. Peace out, people.